So yesterday we have dealt with the array manipulations, right? Up to we saw up to the delete and append and all those things, right? So I was giving you questions of the unique one today. Today we'll complete this NumPy. Okay. From tomorrow we'll be starting the data structures. Okay, learning about the data. Okay. So today's agenda is to find out the functions and to understand the string operations of the NumPy, the mathematical functions, the arithmetic statistical functions, how to sort, how to search anything, how to count for things in the NumPy, and various things are there today. Okay. So we'll first start with the string functions. Okay. So let this be. And as said yesterday, today we are having test here from 4:45. Okay. So in the string functions, you have some major 4-5 functions. Now 4, 5, or 6. Like kind of 9 to 10 major functions are there to write down. Okay. Now see, I'll discuss one by one. So the first function is the add function. Okay, I'll be writing add. Uh, if you need definitions, I'll be writing. So with the add, this will returns you the element wise addition, or you can say element wise string concatenation kind of thing, right, of two arrays. That's it. Okay, so how it happens, let's remove this one. Okay, how it does it, see, let's take x, it will be np dot array, and this be 1 2 dimension. So these are my two arrays now, right? So yesterday we saw that to add on these, or to just do a horizontal stacking and all this, what we did is we just added up like concatenation of x1 and all those things, right? Today we are just ahead of that. So now to add on these, we have a function called as add, and there we pass on the values of x and y, and we get results. That is additions of the individual element wise. Okay. Similarly, there are functions like this add, you have functions for multiply. Okay, so subtract is also there, so I'm not going with all those. So subtract will be there, division will be there, uh, multiply will be there, so you can multiply. I'm only doing the multiply now, so you can go with the subtracts and all. You can see on how it works on. So, okay, so what multiply will give you, this will return the string with the multiple concatenation element wise, right? So let's say if I write np dot multiply vx and vy, so we'll get the multiplication of that, right, element wise. Similarly, there is one term called as center. Now center will return a copy of a given string and with the elements centered in the specified length. Okay, how? Let me show you. We also have center. Okay, so you see, with the center method, what we can do is we can just pass on the value here, and then we can find out, or we can just take this thing as a center, like we do in the strings, right? Those are very similar as compared to the string methods. What you do, someone is there. Okay, so that is similar to one of the string methods. That is your np, not sorry, it is your string dot center, and then you give the arguments there, right? Similarly, you can capitalize anything just by writing it. Okay, you can just capitalize those things by writing any string value, like for the character dot capitalize, and then you can write over there. Similarly, you can get for lower, upper, split, splitness, and all these things are same. Whatever you have learn in the string, right? What when you learning the Python, when you learn about the strings, so everything comes here. Like you have to write the np dot, and then the functions, whatever those are, right? So you can go to the string one, right? So strings are very similar to that. Next, we come up to find whatever we have dealt in the SymPy, that is what that were kind of trigonometric functions, right? So what was that trigonometric functions? So in the trigonometric functions, what you can do, here you can convert like for the sine, the cos, and all those things, whatever we have that in the SymPy, right? So that you can do here in the trigonometric functions of the NumPy. That is easy to do here also, right? So how to do that? Let's see one by one, right? So in the trigonometric functions, first of all you come with the sine. Okay, first of all this is like for sine 1. So let's study the sine. So sine of any function will give you a trigonometric sine of that particular thing what you write, right? It can be x of any parameter. So you will be giving angles in the radians where 2 pi radians is equals to 360 degree. Okay, and you will be just like doing something. Let's say np dot sine. I'm just finding the sine, and let's say I want to find the value of pi by 2. What is this pi by 2? Pi stands for 1. I'm finding the sine of 180 there, right? So I'll be getting 1.0. That's correct. Okay. Similarly, you can even have a proper array, and then you can find out the sine of those things, right? How you can have a proper array like sine of an array, array. Okay, and then you can pass on your values to that. You can write it as 0, 3.5. Okay, let's take some standard inputs. Whatever we have done, that 0, 30, 40, 50, 45, 60, and 90, right? And we'll multiply this by 180. Okay, you'll see the values. Oh, so these are the value and sine of 0, 30, 45, 60, and so does the 90, and you have all these values, right? So you can see a sine graph also just by writing just plotting a graph with the sine one, right? Remember we have read till the matplotlib, so we can just write on or plot the things, right? Kind of, let's say import matplotlib dot your plot as plt, and let's say my x, let's make x as np dot linspace. Okay, and let it be minus np dot pi to np dot pi. Okay, that is minus pi to pi. Let's take 200 numbers from this, and let's print your X label as angle in the radians. So this will be a sine graph, okay? And you can also write the axis. If you want grid and all those things, you can just pass on the functions and you can just print it there. Y label. Oh, we didn't plot the values. So while we're plotting x and the np dot sine of this x, okay, and we'll see the value. So this is your sine graph, right? Similarly, you can find out the cos graph or a sine and all those you can find it, right? Similarly, we have cos. Now definitions are not needed, I think, right? So just make a program and we'll find out. So cos is again same. You just pass on a cos to any particular values and you can find out that. Let's say you have been taking for 0, 30, 45, 60, 90. Right? You can just pass an array of that, and that will be a cos of this. So you can just find on everything there, and you can even multiply it by y. So that is the values you will be getting on. So let it be there, like cos of this. Okay. Who is there? Sahil. Okay. So costs will work like that. So similarly, there is sine, you have tan and all those things, right? So let's see the tan. I will seeing all the three major ones. Okay, not every. These are the three major. Then you can find out for all these like kind of reverse of that, right? That are easy. So that can also be done with the tan. Also, you can find the same things if you just copy this all. And also you can represent these things. Okay, you can also represent these things in the form of mathematics, right? For representation, what you can do is you can pass on these things in the simpy and then you can just write the values of that, right? Remember the simpy how you write everything there. So let me practice, that's all. You can practice on and you can find out the values of those things, right? So there are things, okay, so you can convert anything like kind of the radians, you can say, right? So for finding the sim, you can say sum or products or subtraction of that, right? So there are some of the functions which you might get some kind as exp or exp rf or like that, right? So let us do one by one. So trigonometric functions basically first go with the sine, cos, tan and all those, right? Then you have degrees and radians, those are important. We have discussed in these simply, right? So let's discuss the radians and the degrees. So in degrees, if you write np dot degree and all those things, so it will give you true results, or it will give you an output of, or basically it will convert the angles from radians to the degrees. Okay, so you need to give some of the radians and then you will be getting some degrees over there. So let's say your radians is I think let's take okay, this is my radians. I can print to see my radians, right? So these are the values. That's good. Now say if I want the degrees of my radians. So these are the degrees, right? So this is 0, this is 30, 60, 90, 120, 150, 180, and this stands for all these things, right? It's kind of, right? So you can also find the like shape or anything for that, right? You can find all those things. So this is a kind of degree. Similarly, you have radians. So radians, what we'll do in the radians, this will be converting your angles from degrees to radians. Okay, now you know these are the value of your degrees. So we'll go with the radians, and there, okay, there will be writing on degree is equals to NP dot a range of 12.0, and we'll multiply it by NP dot pi. Or now we don't need to convert, right? So let's just say it's 30. So I'll print my degree, and you can see this as these are the degrees, right? It is 0, 30, 60, 90, and all those are the degrees now. Now I want to find these in the radians, so I'll be getting the exact, right, these values again. So for that, what I have to do is I will just writing on that I want to uh, print on, or I want a radians of my degrees, and that will be the result. I'm getting exactly the same results, right? So you can pass on the values, whatever we have until now, the 30 and 60, we are getting the values over there. If we pass on the radian values to them, what if we pass on the radian values? So if we pass on, let's say, we know that for 30 degree, it is 0 point this. So what if I find the cos of this? Or what if I find the sine of this? So these are the values. So tan of this, cos of this, and sine of this have some different values, right? So 0.5 stands for sine of. So this is particularly your 30 degree. So what is the value of sine 30? Right, cos 60 is 1 by 2, sine 30 is 1 by 2. So you are getting 0.5, right? So you're getting 0.5. So what if I remove this and we'll check on? So that will be a change in the values. So let's do one thing. Oh, 10, 10, 10, 10, 10. So there you are getting the values, right? So this is particular the value what you are having. You can represent this in the form of a expression, and then you can get it the exact results of all this. Okay, so these are just the basic of trigonometric, right? Similarly, we have read about the around functions and round functions yesterday. Okay, so let me do it once again. So what does this do? This round or around will round an array to the given number of decimals, right? So let's say that okay. So we saw yesterday, right, that we just pass any value there, and we just saw that the value is converted there, right? So if you just pass on to find the round of any number, let's say, what is around there? Round. So let's say I'm finding the round particularly of, let's say, 16.055 by 2. Okay. So it will get the round of a 16.06. What if I write 3? So you can just better understand by giving the values again and again, and you come to a conclusion with that. What if I 4? So what are then above the 3, what are the values impacting on this round? Nothing. What if I write 1? So I can see this 1 coming there. What is this 2? So I can see this coming there, right? So this round particularly, if you go for a good definition for this, so it rounds the numbers, it evenly round the number to the given decimals. Okay. So you have, this is your number, you have given up to 2 decimals. So it will evenly round it. Okay, it will round it evenly there. So let's say this is something more, and you're writing up to 2, so you're getting like that. Suppose you write 4, so you'll be getting there, right? Up to the 6, so you'll be getting up that. Okay, so you'll round off to the numbers whatever you give. Okay, that's all. Similarly, you have in the mathematics, you might have read about the math.ceil, right? The math.ceil. Many times it comes as what is the use of the ceil method, that is SCEIL, right? What is the use of this method? In math module also you have this. So this return the ceiling of the input, right? Ceiling of the input, or you can say that the smallest integer of it. Okay, you might have read in the math module. That is exactly the same what we do here is, let's say we want a ceil of numbers. Let it be an array inside there. Let's write some arrays. Let's say 1 minus 4, 5.0 minus 0, 45. Let's see. So what are the ceiling things? What do you have actually got as the output? One. Okay, this all will be in float. That is not a major problem. So 1 is 1, minus 4, 5.0 becomes 5, 0 becomes 0, 45 becomes 45. So what the question can be there, that what are the methods which converts a particular float value to an integer using the math modules, right? So what are those modules? You can give it as a kind of a float, as a kind of a ceil. Okay, so 0 doesn't give any minus or any positive values there. So that is just a that is kind of just a positive value. Okay. Similarly, there you have floor and all those things. So floor this time, floor will come in your examination, right? Floor, ceil, fabs, and FREXP. There will be a question given on that. So you will have these things in your exam, right? So this what floor does. This returns the largest integer, right? So this will not give you any kind of that. So this floor will give you an largest integer, and the ceil will give you something else, right? So there are terms when you go with the mathematics ceil that will return you the smallest integer, right? But not like not less than the number. Whatever the number is, it will give you the smallest integer, but not less than the number. Let's say you are writing as 1.5. So it will give you the smallest integer, but not less than the number. Okay, so what do you see? It's 1.5. It is getting to 2, right? It is getting to 2. So that will give you the smallest nearest integer, but not less than the number. So the nearest integer from 1.5 would be 2, right? So that is the thing in the C. Similarly, when you go for like floor, right? So when you go for the floor, so floor particularly what does it? So floor will return you the largest integer, but not greater than the number. Okay, that will return you the largest integer, but not greater than the number. So let's say I'm writing as floor of np dot. Let's just pass on these values. And let's just say that this is a floor. So this will return you a kind of largest integer, right? But not greater than the number. So that is the difference. Here you are getting greater than the number, not less than the number. Here you are getting greater than the number. Okay. So here what you can see is that the float values, or let's say removing the floats. let's say I remove the float, right? So what happens now? And np dot of this all, and let's say okay, so let's say this to be data type 16. Still you will be getting a float data type. That is a problem then. Okay, so you can use math module to find out all these, but that is good if you are getting in the float value. That is a good one. Okay, so these are the basic functionalities of the float, right? In the math one, you have seal, floor, fabs, logarithmic values, right? So log is there in the NumPy also, right? Now I'll be going to do the exponents and the logarithms. Okay. So in the exponents, what will happen? You will be getting, or you will be calculating the exponential of elements, right? When what you give in the array, so you'll be finding the exponential of those things. So how to find that? Let me just write on the let's just say that I want to find the np.exp, and now I'll be passing on the values. I'll be just writing the exponents there. So I'm writing as just 3 2. Return address must be of same time. Okay, let's give it as. So you can get the exponential values of these things, right? So that can be done with this, right? Similarly, you have log and all those things. So what is the log one? What happens in the log? So log comes basically as log, and in the math module as you have the log and the log 10. Similarly, in the NumPy also you have log as well as the log 10. Okay, so this will give you a natural logarithm if you use np.log itself and nothing else, right? So if you only use this np.log, you'll be getting a natural logarithmic value. And let's write it as exp. If we write for the log, so here what comes if I just write an np.log, and we'll pass on the values np.array, and let my arrays be 1, the logarithmic value of exponent e squared, and 0, and passing errors there. Okay, so you can find out the logarithmic values by this. That is the log of log 10. Similarly, you have log 10, and meanwhile you can give your own base value to find out the things, right? So if we go with the log 10, so there you have, let me just copy this and paste. Only the difference would be you're getting a log 10 value. So this is a kind of log 10 you are getting, right? So that is very easy to calculate if I just write nav np.log 10, and so that is one example, right? So you can pass on the values, you can even pass on the arrays, and you can then find out, right? So there are functions for that. Okay. Similarly, as I said, for the arithmetic, you have addition. You can just get the positive numbers. You can find out the negative numbers using casting, right? You can just do a casting one, and you can find out the positive and negative numbers, right? So there is np dot positive, which will just give you a numerical positive value element wise. Okay. They have negative. Negative will give you a values according to negative ones, right? How? Let's give me an example for that. If I write it as positive Okay, so in positive, let's write np dot positive and let's pass the values. Let's pass some value. Let's say -1, 0, 45. So what you can see is this is an positive, but what you have got is kind of a numerical positive values, right? So these are not numerically positive values, right? So what you get is n like array, what you have done, and what you return is a scalar one, that is y equals to plus. Now let's say it will be clear to more if I just give you a good example for that. Let's write it as np. Right? Let's take negative values. 3, 4, 5. These are the values. So np dot positive of x. So here you will be getting the values, right? But you need to check on the values whether this x is equals to this positive value or not. So there you are getting some true results that positive numbers are having some positive results, right? That is nothing but these are the values. Now these are negative values, right? And this positive will give you a result like positive. You can not understand it like that. If you do with some of the problems or questions with that, then you will come to understand. Let's say I'll give you an example for it. Okay, let's take the reverse of this and then you can understand. Now let's say that you want to do a negative of this x, right? That this is your x and you want a negative of this. So what if there you, what will be the results you will be getting there? Let's see. So you can find out the difference of the negative of this x. So you find that the positive one is remained as a positive, and the negative one or the negative of that will be this 3 and 5, and then you have got this one as the negative. Understood? Now I think you might be clear of that. What are the positive and what are the negatives of these things, right? So this works as like this. Okay. Similarly, you have your uh, kind of, let's what to say that is mod, right? So we can find the mod of anything. You can find the mod remainder, right? So mod is particularly giving you the remainder itself, right? So there is an optional one for modulus or the remainder also. So you can find on the mod, like if you write it as mp dot mod of 10 5. So there is invalid arguments. Okay, so you can find mod is not working, then let's use the remainder. Let's say 10 by 5. Okay, nice. Okay, it's working. Why is not mod? Any parameters changing there? Remainder. Okay, it has been just changed to remainder itself. Okay, so mod is now working as a remainder one. Okay, so you can work with the remainder. Any examples for the mod? No, it is working as a remainder itself. So you can write for the remainder and then you can work it, right? Similarly, we can go with the positive, negative, so divide and all those things, right? You can go with the floor or right. So that are the things. Now we have seen the complex type that we can find out the complex values, real number or imaginary number. Similar to that, we can find in the NumPy, we can find a conjugate of a complex number, an angle, a real value, the imaginary values, and all those things. So how are those calculated? Let's say you are calculating a, this was a remainder, right? Positive and negative. negative. Alright, so here comes the modulus. Let's write the remainder. Let's make this above. Okay. So we'll see for the complex one. So complex comprises of 4 parameters here, right? So let's say this is my y and this is my array, and I'm passing some values, let's say minus 0.4j, let's say 10, let's say 24 plus 3j. Okay, these are y. Now you can find the real part, you can find the imaginary part, you can find the angles and all those. How? If I find the NP of real of this y and the NP, okay, let's find the real part. So these are the real part, right? That is 0, minus 0, 10 and 25. These are the real parts, minus 0, and there is nothing, so that is also 0. Similarly, you can find the imaginary part, and that is a y. So these are the imaginary parts, 1, minus 4.j, 0 and the 3. You can find the conjugate of that. Okay, so conjugate of that will be given by j, and then you can just find out the y is not defined. So you can find the conjugate too. So conjugate will be given as this. Even if you find the angles of this. So angle, this is AIML. So angle is nothing but the degree, or what you write it for, right? The degree of those things that will return the angle of the complex argument. Okay, that is there. Meanwhile, you can find the square of a number, you can find the minimum, you can find the absolute number of any particular thing, right? So these are the basic functionalities or the mathematical operations you can get it on with your NumPy. Okay, apart from this, let's work where it is our point. So till now what we have seen is, we have seen how the random works, empty works, linspace, arrange, zeros and all those things. We haven't seen these things because these are not very much important, but I'll go to it. So we have seen the data types, that is integer 64 are signed, that's 64-bit integer types, float and all those things are there. Unicode are the Unicode types, right? Now we'll see the standard deviations go in these these functions. Okay, we'll see now. Copying arrays and sorting and viewing arrays, I'll make you see now. Sorting arrays will also see now. Comparison will see, and till now we have seen that exponent of something will give exponentiation. Similarly, the square root, cos, log. The dot is particularly the dot product we saw yesterday, right? And you can divide, add, subtract, anything like this. Okay. For information, you can write on the asking for the help, and inspecting your arrays, you can just write on length of this, number of dimensions, size of the array, data type of the array. Data type dot name will give you the exact name of that, and as type will be used for converting an array to any different type of an array, like for the float to complex or integer or any of the things, right? And we have seen the subsettings, that is your element indexings, right? Slicing we have seen, boolean indexing also we have seen, right? And we'll do it today again once. Array manipulation, we have seen the transposing of the array, changing of the array shapes, reshape, and the levels are there. Okay, and adding or removing, we have seen resize, append, insert, delete. Combining arrays, we used v stack or h stack, the column stack, right? And that can be written as r underscore or efn, that is right. We have used the elements to the splittings of h split and v split, right? So these are the things cleared off. Okay, tomorrow we'll be starting with these pandas. Okay, data manipulation, that is very important. Okay, let's go with this now. Okay, so these are the basic things we have till now, the mathematical operations and all those things. Similarly, there are a lot of operations for this, like for the trigonometric what I discussed. There are trigonometric operations and arithmetic operations we have seen, right? So arithmetic, you have addition, subtraction, multiply and divide of the two arrays and you can get it there, right? So you define an array and then you can just add on, multiply it, anything you can do like that. So let's see some arithmetic operations. So arithmetic operations, for that, let's first make an array. Let's make it a np dot arrange, and let's say my data type to be a float and 64 of that, and let's say to reshape this data to 3 cross 3. That's good, and we'll see our data, that is 0 to 9 will be getting the values, that is this. Okay, now let's make another array of 2 y is equals to np dot. Let's make it as okay. So you can do with this with the array. Now this is your y, this is your x. Right? Let me print your y. This is your y. Now you can have operations like x plus y. Instead of this, you can do it like x dot add of y. Add is not working. Oh, sorry. np dot add of x comma y. So you can have both the operations at the time. You can just add on. You can write dot add, and you can do like that, right? Similarly, you have multiplication and division and all those things. You can just write subtract of x comma y, np dot divide of x comma y, np dot multiply of x comma y. Okay, so you can find out these things. These are the parameters or normal things of the type, right? You can find the reciprocal of any number, right? You can find the reciprocal of numbers, right? Let's say this is your a. Let's say this is your a, which is np dot array, and let's say this to be 100, and I want to print the reciprocal of this a. So I'll be getting the reciprocal of a, that is might be 0. So after applying this function, you'll be getting 0. But instead of that, if you have an array having some numbers there, let's say, so that will be giving you, okay, there is some np dot 10 reciprocal of this and array y. Okay, let's see some point values. Let's see, 25, 1. Alright, so float values are working there. You can check for the power function. Now power function works as you give the power, like let's say you have a, okay, we have a, right? So let's see the power of this. So power of a by 2. So these are the power, right? That a to the power of 2 you are getting. So you can go for the power. You can even go for the remainder. So we have seen the remainder, right? Angles and all those things. Now we'll go for checking for the statistical functions. So statistical functions means like what are the mean, median, mode, and all those things, right? So in the statistics, first of the thing is you find out the maximum and the minimum value. Okay, whenever you get to work with the data, so what you do is first of all you go for the finding on the or maximum and the minimum value of an particular data, right, or particular column, array, anything, whatever you want. So you go for just calculating out the minimum and the maximum value for that. So let's say I'm having data. So let it be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is my x now, let's say. So if you see your x, this is your x looks like. Okay, now let's say I want to find out the maximum number from this. So I'll be writing it as np dot max of this x. So this is the maximum. Similarly, np dot minimum of this x will give me the minimum value. Similarly, there is mean which will give me the mean of that, and there is median. These are the basic things. It will give me the, oh sorry, there is a parameter missing. So this will give you the median of that, right? So these are the basic statistical methods or inputs what you use, what is necessary for that, for using those things, right? Uh, yeah. So you will be wondering why we haven't used this mode and p dot mode of this particular x. So because NumPy has no attribute of mode, you have to import it from the SciPy. So from the statistics we import this mode. Not fine, then we can go for the SciPy. Stats. And you can find out the mode that from the SciPy, right? So if I had found the mode there, that is 111 and all those things, right? Okay. Basically. So you can find the mode step, right? Similarly, you can count off for various things. I'll be discussing it one by one there, right? I'll be going with okay. So we'll be discussing it ahead of that all. So let's see if I just find out np dot average. These are the things, guys. You when you try to train your models, and when you try to make some algorithms, you want some statistical data, right? So for calculations, you actually don't need to find out all those things, but you need to have an idea of how these things works. Okay, because when you pass on the functions like for linear regression or any kind of that, right? When you pass the module, that module or that function itself is having all the this mini functions, or you can say as all the inbuilt functions, everything are there to used which are used in the training a model with the use of linear regression. So that is the problem when you train a model, any model which is not supposed to be trained using linear regression or logistic regression or any any other method. Okay, so which is not to be used for that. That creates a less accuracy, less precision for that model. So that is the problem. So for that you need to have some of the statistical ideas too, right? So you can find out this thing. Let's see, the average is 5.0. That is what you're getting, mean and medians and all those, right? So these are the things. Similarly, you can find out the standard deviation. And what I said, that standard deviation can find it out by using the so standard. What is the standard deviation, right? Exactly. Standard deviation is the square root of the average squared deviations from a mean, right? So that is a square. If I say this is standard, okay, let me write here. So what is the standard deviation? So this standard deviation is the square root of the average of squared deviations from the mean. Okay, so what is the squared deviations? Okay, I will write a formula here to get to understand. Let's say this standard deviation is, or ASTD is equals to, what I said, these are the square roots. Who's the square root? The squared deviations. Okay, the square root of the average of the squared deviations. So let's say this absolute values of the, or first let's say the mean of the absolute values of your data minus the mean. This is how you find out the deviation. I think it's a square root. This is the standard deviation. SQRT is not defined, so you can use NP there. Mean is not defined. So if you see your STD, it will be kind of this, right? So to find out the STD of this, what I'll do is I'll just NP dot for these standard deviations. You have this STD function, which will just find out the standard deviation. So the proper formula for finding of a standard deviation is this: that you find the square root of the mean of the squared errors. Sorry, not squared errors, squared deviations. Okay, and that is your standard deviation. But there is a method in the NumPy that is you just np dot standard deviation, and you will get the values from that, right? Similarly, you have many times you would be asked in the linear regression to find out the variance. Okay, many times you will be asked to find out the variance. No, variance is the average of the squared deviations. This is the average of all these things. So variation is the average of the squared deviation. That is kind of mean of absolute. This particular thing, that is mean of absolute. So this is the squared deviation. If you go for the understanding this particular thing, this is the squared deviation, and the standard deviation is the square root of the squared deviations. That's all. Okay, so you can understand it by that. If you want to make a note of that, you can write it as squared. A standard deviation is the square root of the squared deviations. Okay, so if I mean to find the squared deviations, so variance, if I mean to find the variance would be the average of the squared deviations. Okay, that would be the average of all those squared deviations. So you can find out that np dot the average. So average of the squared deviations. So if I write it as squared deviations, let's take a copy of that. So now I'll be finding out. So this is my average of this squared deviation. Okay. Now if I use this variance method of this x, so I could get it from this one. So you could have understood that what is a variation on what is many times I'll be using the standard deviation. Many times you'll be seeing a graph with some standard deviations in your modeling. Right? So when you build some algorithms, you will require these things. So you should understand what else kind of, right? Even if you are not from mathematical backgrounds, it is a very easy thing, right? You find the mean and then you find out the squared deviations and values. Let's take it as a mode as a markdown, make it a variance, and you can, okay, this is a formula. What I have written is, okay, that is not a np dot mean and all this. This basically the mean of the absolute values, and then you get it. Okay, so these are your variations and your standard deviations. So particularly you can sort anything, you can sort any kind of arrays using the sort function, right? That will sort an array particular. Okay, now let's talk about the data distribution part, guys. So data distribution is done using a function called as choice. Okay, that choice function is used to distribute the data over, and you get to understand this. So if you see, this distributes the percentage of the data, or it generates a random sample from a data to give you there, right? So what happens there, let's say for an example, if I write it as random, so this is particularly learning the choice, very important method this is. Okay, so there what you do is, let's say you have written this random from, this is a function in the random one. Okay, so you use from the random choice and you pass on, let's say you have written 5 by 3. Okay, that is a random dot choice of 5 by 3. So what you have seen that it is creating random integer to 0 to 5 to 3. Understood? It is same as it is creating an random integer from 0 to 5 in the intervals of 3. Understood? That is a random dot choice of 5 by 3 means. Okay, that can be any values, right? That can be any values. So let me write the comment, otherwise you will be misunderstanding of that. So random, this is nothing but the random dot random of 0 to 32 in the interval, sorry, 0 to 5 in the intervals of 3, that's all. Okay, so this creates a uniform random sample for this. That can be anything. Now to get a non-uniform sample, what you do is to give the percentages. Okay, you give the percent. So let's say we have written np dot random dot choice, and now I want some numbers as 4, 5, 6, and I have given this percentage as 0.3, 0.6, 0.1, and I say that size of this should be 100. So what you can see is I have got an array of 100 numbers, right? That is 100 size, and the data itself is filled with only 4, 5, and 6. Okay, and most of the time I can see the number of 5 is much because I have given this 5 a percentage of 60%. Okay, that is 0.6. So I have got to see that this 0.6 has been given as a 60% values for the data. 0.1 is given as 6, so I can see 6 for very less time, right? So with the unique one you can find the data. If we just find this as a choice one, let's say this is a choice. If I write it as choice and if I print this, you can see the data is there, that this is my random dot sorry, these are the choice there, right? So what you can do is you can find the uniqueness also. You have read what is unique, so you can find the unique of this choice, and that is particularly the 4, 5, and 6. You can also find out that, okay, don't need this actually. You can also find out the counts of this. That is, 4 has been printed for 33 times, 5 has been for 59 times, and 6 has been for 8 times among of this 100. Okay, understood? So this is your count of this 4, 5, and 6. Similarly, you can find out that what are the index values. If these are being printed there, then what are the index values? So you can find it by the index, that is 4 starting from the 0 position, 5 starting from the first position, and 6 is starting from the 12th position after sorting these values. Okay, how? So 4 you can see it's starting from the 0 position, 5 starting from the first position, and the 6 starting from the 12th position. Alright, now you have seen this is a kind of a random one. Now to sort this, what we'll do is we can sort it with using the function called as sort. Right? We can use this sort to sort anything, right? Let's say you have used sort and you pass on this choice. So you see, we can see a sorted kind of data here, right? So that is a sorted. Now, if I want to insert, if I want to just insert some values, let's say I'll be dealing with the where method now. Now let's say I want to insert some of the values to this choice one. So I want 1, 2, 3, and 8, 9, right, kind of that data. So I'll be seeing where I can insert this 1, 2, 3, 4. Okay. So where I can insert this 1, 2, 3, 4 in the X. How? Let's see first remove this. One, two, three. Modules are here. So first let's find out the data and then we'll insert. So see, what I can do is I can find out the values where this value are becoming 5 or like that, right? So I can search on this where this choice values is equals to 5. So these are the index locations where the values of this are the 5. Okay. Now don't go with this sorted one, go with this one. So these are the index locations where the value are 5. Similarly, I can find out where are the choice values greater than 6. Nothing there. Let's say greater than 2. So these are the places of where this equals to 5. Don't let's greater than 5. So these are the index locations, and these are the only values which are having 6. Okay. So if I just print on that np dot, or if I print choice and I give the values as this, then you can see that all the things I'll be getting will be the 6. So that is saying that choice has too many indices for the array. Okay. So go with this. We can apply the loops here, but this is not much I'm liking there. Choice. So I can see everything as the 6 there, right? So these are, so you can do particularly every calculations with your data. You can sort. So sort can also work you with here. Let's say writing some of the things. Let's say I'm using sorting function and I'm writing some. Let's say some of the game names. So let it be COD, kind of what I play. What else? Yeah, GTA, and that's it. So if you want to just sort these things, so it's taking integer and integer required. Why? Okay. So you can see the sorting has been like for COC should come first, and then COD should come, then GTA, and then this PUBG should come there. So this sorting can be done with the help of this, right? You can find out these things, and that can be done with this, right? So meanwhile, let's say that with this where one, with this where, let's say that I'm creating a as a range of some 10 numbers there. Let's say this is some 10 numbers, and I just print on this A to CO. Right, this is. So there are some 0 to 9 numbers, right? So if I find that where this a is less than 5 and where this a is multiplied by 10, right? So you can see the values what you are getting is a is less than 5 a and then a oblique 10. So let's reduce this and see one by one. So a is less than 5 is 0, 1, 2, 3, 4. Okay, then I'm printing a. So the code of function will be given here that current. So this is a, and then just remove this. Let's go with the a and a by 10. Okay. So what you can see is a multiplied by 10, you are giving the values of a multiplied by 10. So only the numbers less than 5, after less than 5, the numbers what you are getting, that's only with the a less than 5 with the numbers. Then you are having a, and after that, the a multiplied by 10, that is after the numbers which are less than the 5 will be multiplying with the 10. So they have 50, 60, 70, 80, 90. So that will not count as the 5 less than 5, so there are 4, right? So from the 5 itself we are starting the multiplication there. So that is the use of where you can do, right? You can calculate, because when you will learn the data structures and algorithms on those things, so you will be dealing with the NumPy arrays, and that will plays a very important role there, because you will be having everything in NumPy when you load an image or when you work with an image also. So there will you will be dealing with only the, where is your, yeah. So there you will be only dealing with the NumPys, right? So that is a very important thing. No, not here, where it went off. Yeah, so there is one book particularly I have downloaded it. So this is a SciPy and NumPy book. I'll share to you guys. Okay. So you can find out many things of the NumPy, right, from the Boolean statements and arrays, interpolations. SciPy is having a lot of things to for the image processing and all those. And small book is there, right? Not a big one. But I'll share you the cheat codes that you can work with that. So there are operations working here. Okay, NumPy is there. You can convert in yeah, that is to convert an in the array to list. So you'll be using this to list function to convert anything in the list, right? And some of the things are right not discussed. That is, you can find out the metrics, and that metrics will give you an error like that. Okay, here because 3 is given there, right? So there are something much more you can experience in this one, in this book. Sometimes S type is left off. Let's focus on that. So let's say you have having a X, which is an array, and you are saying this array to be 0, 1, 2, 3, 30. Okay, and you are saying this data type to be integer 64. So this is an this integer, not let it be a float value. Okay, so what is X like this, right? If you don't like write this one, what is this X? This is an X with a data type of float. So what there was that you can also find the data type name. So that will give you the data type name, that is a float 64, right? So just see the X now. So X is having a data type of float 64, that's it. Now I want this X to be an S type of integer 64. So I'll be saying the X values as an integer value. I can go with the any one type, that is X dot X as type, and I could search on for these Boolean ones, and I can get the Boolean values, that is true, false, true, and false, like that. Okay. So why this coming as false, true to true? Because 0 is not meant to be having any true values any time. Apart from zeros, every time you will be getting some true results, right? So 0 will always giving you a false result with that. So this is how you deal with the choice and where and all those things, right? Similarly, if you want to find the LCM or like the HCF of any array or number, you can find out with this, right? So let's say you are finding the LCM, you want to find the LCM of a number. So you just write the LCM and pass out the numbers. Let's say I'm finding the LCM of 2 and 4, it's 4, right? So let's say LCM of 2, 4, 6 and 8. So you can make a very good calculator too with these things, right? So invalid number of arguments. So if you want these much, like a lot of numbers to find the LCM of this, so what you can do is you can reduce this thing and you can find the LCM of that. 1 second. Module LCM not reduce. There's something problem. I have written a wrong statement. Use was given, I think it was dot over there, so that might work here. This is not defined. Okay. Yeah. So for finding those things, so for an array, if you want to just find out LCM of an array, like 2, 4, 6, 8 will give you an LCM of this, right? So you can use with these things. Also, you can find out LCM using the arrange one, that is, let's say you want some 6 and you have given 20. Okay, so you want the LCM of every individual numbers with the 20. Okay, so what will be the value? That is 0, 20, 20, 60, 20 and 20. Okay, so you can find out the LCMs one time. For one, what you can do is you can give the values, so it returns you the lowest common multiple. Similarly, you can just find out the HCF, that is your greatest common divisor, right? That is GCD. So you can find GCD as you can write on np dot GCD of some 2 values. Let's say it's 12 or 20. So that is 4. You can find out for an array also, that is np dot GCD dot reduce of x. So you can find that those things, right? So this is particularly similarly you can find the LCM, GCD of this one. You can get the GCDs, right? So what is this? What you are doing actually is you are having a range of 6 numbers, that is 0, 1, 2, 3, 4, 5, and you're finding the one by one of this with the respect of 20. They are getting the values. So 0 with 20 will get 20, 0 with 20, 1 with 20 will give 1, 2 with 22, 3 with 21, 4 with 24, 6 with 25. That's sorry, 5 with 25. As the things you can get with these NumPy ones. Let's see what else are remain here. No, not with this. So as I said, I'll be giving you some questions on this, not today. So you will be getting an assignment on the NumPy, and that will be having some 100 questions. So we have seen these all the things, right? So, meanwhile, you can pass on the things to find out the. Okay, there is a one term left off, that is coefficients and your. Okay, so let's say GCD has been over and as type has been done choice. Okay, let's say that I have an array x, okay, and I'm saying that I want to replace the value of x with the 5. So if I see my x, so the first value has been replaced as 5. That's okay. Now let's say I want to see a copy. So that is the difference between a copy and view. Very important, that is topic. See, in copy, what happens if you create a copy of an array? Let's say this is x dot copy. So if you see a y, that is this, right? Now if you change on your things in the y, if you say that y of 3 to be 3, so y will be changed to 3. The third element will be changed to 3, right? But if you see your x and y, so you can find out that this is the same as it was, and there you have the value of 3. That is okay. But in place of view, what happens? It will change the value from the original array also, and the changed array, that is what you have done, right? So if you say that z is a copy, view is view of x, so z is a x dot view. So this we use when we want to change the original data also. Okay. So you can now let's say that the set of 0 to be as copy view. All right. Sorry. It's 12 there. Make a list and then you can write on change it there. So if you just print on your x and z now, or x, y and z, you can see the difference that this is your x that is having 12, 4, 6 and 8. Instead of this, what was before that, it was 5, 4, 6, 8. That is your copy. This copy is 5, 4, 6, 3, that we have changed the values. And you can see the z, we have passed the first value as the 12. So we can see the copied, the viewed value, that is 12, 4, 6 and 8, and the original value of that is x, that it is the same one. Okay. So that is a major difference in the view and this copy. So if you go with the definition, so view is an array with the same data. Okay. View is a new kind of view with the same data. So it is not like doing a replacement. It is just changing the original data. So if you do the copy, it will make a copy, and then you can just work on with a copy of a data. But when you make view, you make a new view of that data, and you are just working with that data itself. So that is a confusion many a times, right? So view is kind of a two different ways, right? For the some data types, or you can use with some any other data types you want to do. Okay, so view can be done with two of a kinds, right? So this was all about the NumPy, what you do with the help of NumPy. Let's say let's say I'm giving a basic question. That day we did about some questions on this OTPs, right? So let's say that you want this for x np dot. Okay, now you can make anything to the list, as I said also. So let's say I'm making a range of some 20,000 numbers. Let's say this is an OTP. Okay, so let's say this is x I, or let it be anything. Okay, and this is an np.arrange, and then let's say that this will be c will be equals to np.random dot randint, and to pass on some values, let it be any particular value, and let's say this I to append this g plus str of c, and at last we'll make this as an array of I. So there is one syntax error where it is I is equals to 4x in this I dot append. Okay, let's just make this. There might be an indentation error, I think, or I think this error is there. Okay, fine. So this was the error. Okay, cool. So this has been done, right? 20,000 numbers has been taken on, and there you can see. So let's see the I and the first 5 numbers. So these are the first 5 numbers, right? So let's give some gaps and make it again. So these are the first 5 codes, right? That is, I'm getting 1, 2, 3, and all those, right? So see, guys, what I say now that if I want to see the common elements, so let's see the length of this I. So this is this is 20,000. Okay, and meanwhile, if you just search on for the length of this uniqueness of this I, so this is 19,768. Okay, so this is the length, and that is the uniqueness of your I that is you're having. Okay, similarly, let's just take the values, or let's just see the unique values. Okay, so for unique values, let's say this is x and y and z, and now I'm passing the values. Let's say I'm writing an np dot unique, and I'm seeing for the x the return counts to be true, and the return index to be true. Okay, so these are my x, y, and z. So if I see the x of first 10 numbers, so this will say why it is coming like that. Okay, that is I. So if I see the x of first 10 numbers, so these are my codes there, right? So these are the first 10 codes. Let's say only for the 5 ones. So these are the first 5. Similarly, let's print the y of the first 5. So it is having these values. Okay, and what are the index? I'll compare what are these things. Okay, so these are the index values, right? So what this says that let it be the first 5 values 1 2 3 4 5 1 2 3 4 5 and 1 2 3 4 5. Okay, so this x returns you the I, that is the original my data. This z is returning in the this z is returning in the index value, right? The index positions, right? Z is giving you the counts or index positions. No, z is I think giving you the index position. Let's say. Well, see, what is the x of 3? It's 10028. Is there a 1000123? 10028, 0123. That's good. 0. Okay, yeah. So this is giving you the index positions. Okay, and so why this is coming the 00237. Okay. Yes. Okay. Alright, so it was giving the count of those things. Yes. Okay, so see what is being displayed here is that this particular thing is being repeated for one time. This is for one time. This is for one time. This is for one time. And this code that is 1000288, it is repeating for 3 times. Similarly, if I just make my data large, let's say for 50, I'm checking now and making data a bit large, so I can see the first 50 is now having some, this is particularly having the 3, and there I can see only the repetitions of that. Okay, so what you can count on that, what are the percentage of your values you are getting there, right? The question might come, what are the percentage of the values you are getting in your data? So what percent of values are there? So let's say what I'll do exactly is I will be finding on the unique values of the y. So it says that hardly a number is having, very hardly a number is having an occurrence only up to the 3 times. Only, understand? So hardly a number is occurring for values of the 3 times. So you can check now with the where function, right? With the where function, you can check where this y is equals to 3. What are those index values where y is becoming 3? So it says that these are the values, that is 4, 3, 6, 8, 0, this 3, 6, 3, 3, 9, and these are the values where my codes are coming for the 3 times. So you can print your x and you can give this reference of all these digits, copy it, paste out there, and you can find out of all these individual ones, right? So you can find out for x of 4, x of 3680, x of 6369, x of 10250, x of 10 this. So these are the codes which has been repeated for more than one number of times, right? So let's say if I find np dot where in this x is equals to exactly this. Let's see what comes. So it says in the 4th position it's there, right? So these are the things which has been repeated for the 3 numbers of times. So the uniqueness are there, that is, this is for the third 3 times, and this might be printed for the 3 times there, right? That is 100. So in the 4th one it's there. What about this one? So you'll be getting the index values particularly. So if you find that where your values are to be 1, so what happened? A lot numbers might be there. Okay, sorry, it will not be there in the x, might be for y. Now you can get around. So these are the values where your values are the 1. These are the index values where these are the values. Okay. So this is how you calculate your data. So if you see your y, let's say I'm printing for the first 200 numbers. So if you see your y, you will having most probably the data has to be common. That is, every number for the 20,000 repetitions, very anomaly the values has been repeated. That is, for many of very sometimes the values has been repeated, right? Or very less than this. So if you see your original original data, that is your I itself. So if you see your original data of I, so if you want to find, okay, we are finding for the x, right? So we can find out that where this I, in this I, where the values has been equals to this. So you can get that information of that in the your whole data, this in the 601 position, the 400 and 4000 this, and this position will having same codes of this. Okay, so how you can print that? You can just find out that I of 601, I of 4512, and I of 12088. So these 3 will be having the same codes, right? So these are the things you can just focus and you can just work. So what do you think, right? these engineers or this like for the data analyst, what their work is. So their work is less like this to just these are the basic works, right? So their work is just to work on the data, to analyze on and to find the very minimized minimal things from any kind of data. Okay, so they break down analysis and they work with, and these are to be generated at very fast speed. So you should calculate these things at very high precision, right? That is very important for that. So you can find out and you can see that how many numbers of this code is having, how many codes are there which is above 10,000, how many codes are there. So you can find it that where np dot where are these codes in the I which is greater than this. So what you can do is before converting before converting, now you can't go with the codes having greater value. You can just go for checking it as a string greater than all these things. So what you will do is you have the random thing that is your C, right? You have the random. What you can do is you can just pass on a function here. You can just see that your C will be equals to blank list, right? So what you can do is you can meanwhile append the values for the C, and that will be not of much use. Okay, that will be not of very much use. So you can make D equals to np dot array of this C, sorry D. That will what is this, not enough values to unpack, expected to 0. mm -hmm. Done. So let's say to increase the values now, let's say to increase some 2 zeros, now we'll have to wait for 1 minute, I think. Hardly 30 seconds, I think. Because as compared to a list, NumPy are very fast. So if it would have been a case of list, it would might be taken around 5 minutes to not probably 5, might be to almost 120 seconds or like that. You can convert, you can check the time also. You have learned that you can just go for the time and with okay done. So you can just give the minus time minus the start time multiplied by the 1000 and you'll be getting that. So these are the codes now, okay, and these are the unique codes. So this is the length, and what you can see here now, the unique numbers are only this. If I generate around 20 lakhs data, so the unique numbers are only 7 lakhs. Yeah, only the 7 lakhs value are the unique one. So this is what happened. When you generate a very less data, you might face less unique values. So when you do a lot of generation of a data in one particular day, so your uniqueness will be decreased, right? So your uniqueness will be very much decreased here. So if I just make this again, the first 50 counts will be like this. So now what you can see, these are G0, G1, G10, G100 are also coming, right? So these are the first 50. Let's see the Y50. Now you can see the variations. From the 1, it has become 7 also, 4 also, 6 also, and there are a lot of things, right? So the unique values of Y would be increased, and it would now it could go up to the 14 also, right? So now the uniqueness values, like there might be some numbers which could be repeating for 14 number of times, right? One second. Okay, so there you can get a lot of things to explore. So where we can just find out where the values becoming 14, because you can see that greater the number of occurrence would be there. So the number greater than in uniqueness you are getting there, the number of occurrence would be less. Let's say that for the 14, if you check on where your Y values are becoming 14, you will get a very less number there. That is only one particular is having a 14. Okay, if you check for the 13, you will get these are the numbers which are having 30. These are the index values which are having 30. If you check for 12, your preference would be getting a more increase. If you check for the 11, and there you can see the data is increasing. So if you check only for the 1, you will be getting a lot of data. That is starting from 1 and going up to this much, 70,000. So that is the preference I'm talking about. Okay, that is 2 will also work the same. Okay, similarly, if I find out this x4 and all this, so we'll be getting some different results now, right? So let's say that only for the 13, if I'm checking for, then these are the values: 14,007, 14,7835. So 14,7835, 10, 36,0048, 36,0048, 52, 56, 93, 52, 56, 93, 57, 34, 58, 57, 34, 58, 64, 51, 30, 64, 51, 30. Alright, I think it's good at 64, 51, 30. So these are the codes, right? So for the 30. Similarly, you can find out where the data are becoming for the 1. So that goes up to something there, right? So if I just print on the first y values, now you can see the transmissions of this data. You can say just a change in your data coming like from the 7 and all these things are coming, right? So let's say now, if any time of occurrence, if I'm saying that, if I'm just getting for the number which is having 7 number occurrence of 14 kind, or occurrence of some these much types. So what are those things? If I see that which code is to be repeated for the most number of times. So this is saying that for the y of 13, so these are the codes which has been repeated for 13 number of times. So let's take out any one among them. Let's copy it. Let's search for this. So let's search where my I value is equals to this. So it's saying that these are having these particular values. There might be some changes, I think. Okay. Yes. There might be some changes over there. So that has to be repeated for many times. So let's see, it's y plus 13. So these are the values, right? So let's see for this 14 one. So only one value. Let's see for the 11. Or let's see for the 12. So these are, that's a 22850. So that is 1. Why it is coming for the 12 number times? So meanwhile you can write the Z2. If I make the index values 2. So let's see the Z also. So here I am getting the Z. And the Y is also same. Okay. So there was a change in Y. So that has been replaced. So 27176. So it's in the 735089 number, right? So you can check on the things. You can just write. Okay. So I think you might have understood. So you can check on, and we have dealt till now everything with this NumPy. So you can reshape, or for working with more in the NumPy, what you can do is you can work for the reshaping of your data. I think it's there in the pivot, right? Yeah. So you can use to we'll study in the Panda that how to work with the data, how to make it duplications and all those things, right? So we'll do one by one there. And similarly, there is for Matplotlib we have done all those things, right? How to make up plottings, and I'll share this. And similarly, this is not of your use. Seaborn will no. This is Seaborn is also not in your course. In data science, we're having this importing data analysis. No, not there. Jupyter Notebook. SciPy is there. I think that's there. So in scikit-learn, we'll try to understand. So this is the whole sum up of your session. When you will start learning this, your session will just go on the sum up, right? So there will be learning how this is the basic code for every time you'll be needing it there, right? We'll try to load the data. We'll try to train and test. What are the training and testing? We'll learn about that. What are the standardization process, normalizations, and there are a lot of things, right? So in the supervised learning, how we predict the labels, how we predict the probability, in the unsupervised learning, how it does, right? So there are a lot of things. We'll learn these methods, SVM, naive Bayes, KNN, right? And how a model's evaluation is predicted. So in the supervised learning, it is predicted using the accuracy score, and yeah. So when you use logistic regression, you find it by the accuracy score, classification reports. Many times we use mean linear regression, we use mean square error and R square, and these are having individual formulas, right? So there are a lot of things to explore, right? Similarly, we have Keras, which is used to do some projects. We'll be using this also. Okay, so there are a lot of things to explore. Let me stop here.